Okay, cool. Hi, I am Emily. I am the developer advocate for Linea, a ZK rollup, and here I'm going to give a crash course on L2. So it's going to be high level, but also low level, and we'll see where we fall in terms of how much you understand what I'm saying. So I'm just going to go ahead and get started. There's a lot of information to cover. So first off, from the start, what are L2s? If you guys aren't familiar, basically, hopefully you've heard of these. Blockchain trilemma. Why is Ethereum it's a pick two situation, right? We have decentralization, we have scalability, and security. We need to choose three. What has happened is we've chosen as a community to focus on decentralization and security, but we don't have that scalability access, right? So what that means is we are going to be pricing out users because of high transaction costs and slow transaction finality. What does that mean? Layer 2 to the rescue. So layer 2s are specifically the scaling solution for Ethereum. What that means is we are decreasing congestion by pulling off the execution layer from Ethereum and then creating that data and posting it back. When I say posting it back, I mean specifically this concept called data availability. So basically what data availability is the guarantee that all this data is going to be published to Ethereum. So this is what powers trustlessness, right? So one common misconception is how many of you guys are familiar with Polygon proof of stake? Right. How many of you guys think Polygon is a layer 2? Okay, actually nobody. That's great. But I think it is a common misconception, right? They have their own consensus mechanisms. They have their own security flaws. Basically, layer 2s right now, data availability is the key to defining the difference. So that's something to think about. Kind of an image of, we all love visuals, so just to kind of show you what that looks like, right, is Ethereum is the monolithic version is taking care of execution, settlement, consensus, data availability. It's doing a lot of stuff. Like I said, again, Linea or rollups in general pull off the execution layer. Ethereum is handling settlement and consensus data availability. How does it do this? Here's another really fancy visual. Basically, there are various ways to do layer 2s. The kind of winning solution for it is rollups. So when a rollup, it's pretty self-explanatory. Definitely what it does is it rolls up all these transactions together and then takes that and then posts it to Ethereum once. But how does it do this, right? So when we talk specifically about rollups, there are two types, ZK rollups and optimistic rollups. How they differ is specifically on the proof verification part. So the proof verification is basically telling you, how do I know Ethereum, how am I proving that this data I'm posting is correct, right? So now we're going to dive into, actually, I forgot about this slide. To further explain rollups, it's composed of a few parts. So we have the on-chain contract. So you're going to have a rollup contract on Ethereum that basically does the storage, monitors states, tracks deposits. The second piece is the off-chain VM. So this is where that execution is happening. And the third piece is you guys might have heard of operators, validators, aggregators, sequencers. That's a lot of words, but you can basically think of them as the people who aggregate transactions and then post that on. Specifically, when I talk about sequencer, that is a little bit of a separate concept. They are the ones who have the authority of actually posting it. Next, okay, so now I'm actually going to talk about optimistic versus ZK. So optimistic rollups basically do prove verification by basically not proving verification. What does that mean? So they're optimistic because they assume that everything is valid. In order for it to be invalid, somebody has to send in a fraud proof. They say, hey, wait, that doesn't look exactly right. Let's run a fraud proof. If it proves that it's correct, then it'll post. If it proves that it's incorrect, then obviously that transaction is rolled back. What that means specifically is this concept of a challenge period, right? So in order for a fraud proof to be submitted or that transaction data to be posted, we have to wait 7 days, basically, to give time for fraud proofs to be submitted. There are workarounds for this. So something you might have heard of with regards to optimistic rollups specifically is something like a liquidity pool. So that's basically kind of a separate entity that says we'll actually just verify it all for you. If you want to post it and withdraw your ETH immediately from the L1, we can do that for you. The only issue here is that doesn't really address the issue of NFTs. The other piece is that is another like kind of hackable element if you care. So liquidity pools is something you might hear as a solution for the challenge period of an optimistic rollup. I don't think it's foolproof, and that's why we're kind of go into ZK rollups. So ZK rollups essentially, basically, instead of waiting for a fraud proof to be submitted, we, proactively submit something called a validity proof. So what that looks like specifically, if you go back to this side right here, the proof verification is done via a zero knowledge proof. So if you guys have heard of zero knowledge proofs, it basically means proving the correctness of a statement without revealing the statement itself. I want to step in here again in case you guys are a little... I have heard a common misconception with ZK rollups specifically. I think when people think about ZK, they think about privacy a lot. And they're like, oh, all this is... but there's a difference between a privacy solution and a scaling solution. So ZK proofs we're using it specifically to like keep the data small, make that faster. That's for scaling. That's not the same thing as a ZK proof for like obscuring your information. So those are two separate things. We are a scaling solution, so I want to point that out. The other piece about ZK proofs that makes it really cool specifically is we think about there's a concept of like recursive ZK proofs. So essentially with a ZK proof, you can have like this information and you can actually put a ZK proof on top of that and make it smaller. And you can put a ZK proof on top of that and make it smaller, right? So there is like what you could call like infinite scaling that is enabled by a ZK rollup versus an optimistic rollup. So when we talk about ZK rollups, we want to dive in a little deeper. So there's this concept of the ZK EVM. And so basically like this is executing, Solidity or like EVM bytecode. And what does that mean specifically? So Vitalik put out this article of 4 different types of ZK EVMs. So when you think about the rollup space, you might have heard a lot of things like there's like Starknet. What else is there in the ZK space? ZK Sync. I'm part of Linea, Polygon ZK EVM, Scroll. There's a lot. How do they differ from each other is specifically in the ZK EVM portion. So at the highest level, we have type 4. So type 4 is language equivalent. It is not bytecode equivalent. So basically what that means is you will be writing in Solidity, but that will compile into something that is not readable by the EVM, like the Ethereum virtual machine. As we move further down, or I guess further down in number, further up this, table, we have type 2 EVM equivalency. So that's basically, it is language equivalent. So that means you can write like Solidity. Everything is going to be directly portable from Ethereum to the layer 2. And it is also bytecode equivalent. The difference here specifically is you can think of like pulling, being farther away from the EVM, I guess, is a bet that, EVM, inherently is not super compatible with ZK proofs. So performance is not as easily achievable. Whereas type 2s and then type 1s, which are fully Ethereum equivalent, then you're thinking about like the easier it is to interact with the Ethereum ecosystem, the easier it is to have the network effects of all the tooling that's already been created around it. Like everything that has already been built around Ethereum works out of the box, right? And so that's the really strong point. This is kind of like that's the win versus, type 4. And I'm not going to read everything on this slide, but it's just kind of the graphical representation of what I was talking about versus compatibility and performance. So type 4, the least amount of compatibility, or it's on the side type 4, but the highest amount of performance. As you go up, that's that. Cool. So now that we kind of have a basic overview of how all of that works, what it means, what is Linea specifically? So just fast facts, Linea is the product of 4 years of research and development at Consensus. It's actually pretty interesting. When we first started, we were thinking about, payment solutions, like anonymous payment solutions. The idea that ZK proofs could be applied to scale was actually just kind of, no one thought it was possible. So we were doing a lot of ZK proof research. And then through that research, we realized actually scaling solutions are possible with ZK proofs. And so that's kind of how Linea first got started. The other piece, like I said, we are on the way to type 2 ZK EVM equivalency, or type 2 ZK EVM, which is EVM equivalent, right now we are at type 3. You can think of that as more of a transitionary stage. When we get to mainnet, the goal is to be type 2. The other piece is we are powered by an award-winning prover. So when you think about like the technical, I guess, underpinnings of how Linea works, we won an award. That's pretty cool. And the second piece is we actually are very new as compared to the other ZK rollups that exist in the space. So you might think like, I think Polygon recently came out with mainnet. We actually just opened public testnet March 28th. So that was like 3 weeks ago, I think, or less than 3 weeks. But in that a little amount of time, we have like a lot of activity, right? So I pulled this morning. We have over 5.5 million transactions, 560,000 wallet addresses, a lot of deployed contracts. I just guess for comparison, I think Polygon might have like less than 1 million transactions right now. There are different reasons for that I can get into later. But there's been a lot of activity. There's a lot of real big excitement. Like, why exactly is that? Like, why are people so excited about Linea? So I'm going to dive into this portion of like, how do you choose where to build? Well, the first piece is there's a lot, right? Like I mentioned, I was naming all these ZKs. There's actually more than this. There's more optimistic rollups. Things are developing. How do you choose? When I think about what I build and why I care about a rollup, there are a few factors that I'm considering, right? So I think the first thing that people consider is like, the reason I'm choosing a rollup is because I care about finality and gas fees, right? So speed of the rollup, how cheap it is, stuff like that. But the next piece is you want to think about liquidity, right? So how much like liquidity is on that protocol. So if you're focusing on building like a DeFi dApp, for example, you want to think about how much transaction volume you can get from there. EVM compatibility / equivalence. So this is where I was talking specifically on like whether or not you want to leverage the network effects. So specifically with like Linea, for example, because we are EVM equivalent, nothing changed in terms of when we were bringing on partner dApps. Literally all they did was just redeploy, right? Because nothing had to be changed. If their code is written in Solidity, it should work on Linea. The other piece is users. So when we are thinking about building a dApp, you obviously want people to use it. So how many people are actually building or like, I guess, transacting on that L2? The other piece is security. So I think this is kind of where the reason people might focus on optimistic rollups versus ZK rollups. Optimistic rollups have been around for a while, so you could say they are battle tested to an extent. ZK rollups are a very new technology. Are there going to be bugs? Probably. We've only been around for like 3 weeks, public testnet wise. But you know, something to think about. I don't think I think this will be a solved problem, but we'll see. And then the second piece is future proof. So I think this is kind of where I'm talking about where do you think the future of this rollup will go? You know, like, is that EVM equivalency super important? Is it going to be able to be fast enough? The other piece is like, is that ecosystem just going to be supported in the long term? Other things to think about. So, I mean, like I said, I think for the most part, ZK rollups have won against optimistic rollups. I spelled optimistic incorrectly. Ignore that. But yeah, I think specifically when I talk about the differences between the ZK rollup on the Linea side, the Vortex is our prover technology. So when I talked about how, you know, you might think about a type 4 being able to be more performant more easily, our assertion is like, actually, our prover tech is going to be fast enough. You have a confused face. Maybe that's not true, but like, that's our bet. No. But anyways, what does that mean exactly? So this is kind of like a high level of what it looks like. So I'm going to name these important parts. I can't explain them directly, but basically we have arithmetization. So you can think of arithmetization as taking like all of the proof can actually prove it. The inner proof system is kind of where that proving is happening. Arcane and Vortex is basically our tech to recursively make that proof smaller and smaller and smaller so that when we submit it to that verification contract on Ethereum, it is as small as possible, so it is faster and cheaper. That's my understanding of this. If anything is incorrect, I will let you guys know when I talk to our researchers. But yeah, so this is also just like another slide of what that looks like. It's very complicated, but basically what you can see is the language equivalency versus the bytecode equivalency and how that compares to Ethereum. So that's kind of all of them. But they're all really good and smart projects, so I'm not here to say one is better than the other. But specifically, why Linea? Like I said, so I think we have the basics of a rollup, right? Cheaper, faster, secured by Ethereum. When we talk about ZK versus optimistics, we don't have that challenge period. Zero switching costs. So that's when I was talking about being able to take advantage of the existing Ethereum tooling system. Something I want to speak to specifically, and I think this is kind of in line with how future-proof you think it is. With Linea, the Linea is a default network on MetaMask. So right now, when you deploy to other networks right now, you have to go through the UX of like hitting add network manually, finding that RPC information, adding it all there. User UX is gonna be smoother. We live in the same company as MetaMask. So there is a partnership in that sense of we're very close to like the most popular wallet in Ethereum or in Web3. But yeah, that's that. The other piece I want to know as well, I think there is a lot of, what do you call it? People like to fight between L2s. I don't think that's necessarily true. So something we are exploring is something called the multi-prover theory. So like I said before, like things might have bugs, right? So at the end of the day, like we're sending it through a prover. If that prover has a bug in it, that's problematic, right? So what the multi-prover is saying is we're actually going to send it to multiple provers. So Scroll, Linea, Polygon is like people we're talking to. If there is a consensus on this is true, we've verified it in 3 different ways. So that is a lot more secure than, for example, if Linea was the only L2 that existed in the space. And so this is what I say when like, we're competitors, but actually it's very important that we collaborate. So yeah, that's kind of the future. The other piece to this too, I guess a sneak peek, right? We are in L2, but we are thinking about like building L3s in the future. That could be anything from more specific like app chains to, again, doing that recursive proof so that it is faster. The definition of an L3 is actually still in flux, which is pretty interesting. So keep an eye on the space. But yeah, so actually what does it look to build on Linea? I think the Wi-Fi is really bad, so I'm not going to do this live. But the first thing you need to do is actually get Linea ETH. Let's see if I can access, if it'll go. Oh, okay, I guess. So yeah, I mean, basically what happens is you're going to need to bridge ETH from Gurley testnet over to Linea. So this is kind of, I hope you guys know how to use a bridge, but you can just think of it like this and then send it over. If this is not working, like I think it will work, you can come to me. I have 2,000 Linea ETH, so I'm happy to share, but definitely like try out our bridge. But yeah, so the first thing you need to do is get Linea ETH to actually transact. The next piece is going to be choosing where you build your smart contracts. So I have an example specifically for Truffle, Foundry, and Hardhat, but because it is EVM equivalent, bytecode equivalent, you should be able to use like Remix, Brownie. I don't know what other people use, but like wherever you build, that's where you choose. So specifically with Truffle, so to actually, I can probably do this. Let's try this. So let's do a Truffle init project. Oh, I'm in a project already. Whoops. Okay, Truffle init project, code project. And I don't have any demo code in here, actually. So pretend I opened this and then, woo, I added all this stuff. Amazing. Wow. What does that look like to actually deploy? So to deploy, and I'm going to show you what this looks like, actually. Oh, I already opened it. So here's Truffle dashboard running. If we go to Truffle dashboard, specifically, you can choose what chain to deploy on MetaMask. I chose Linea. If you want to deploy on Gurley, mainnet, etc., you can do this all here. I'm choosing to use dashboard because I don't want to expose my private key to you. And then you can just do a Truffle, migrate, network, dashboard. And if the internet works, something should show up. I don't know if it will, so I'm just going to show you. This is what it looks like. It actually sends in the transaction. You just hit approve, and then it happens. With Hardhat, actually, you can also use the dashboard. You would just fit it in here, and then deploy with npx like hardhat -deploy RPC, like Truffle dashboard. With Linea specifically, this is our RPC endpoint, rpc.gurley.linea.build. We are permissionless public testnet right now, so that's how you would do it. Have any of you guys actually deployed a contract before? Oh, actually, most of you haven't. Damn, I'm just saying stuff as if you understand. Yeah, okay, I will briefly touch on contract deployment. So essentially, you have various tools. So like I said, Truffle, Foundry, Hardhat that help you manage the deployment process. So that's going to be writing it and then giving you the opportunity to deploy to a network, configure what those networks look like. So if you want to deploy to multiple networks, that would be part of like a configuration that you add to your Truffle, Hardhat, or Foundry project. The other piece is like it offers testing functionality. Specifically, when you choose where to deploy, that's kind of where this network configuration comes into play. If you guys have deployed a contract before, what it looks like is this URL will just be replaced with like early testnet, will be replaced with mainnet, will be replaced with Polygon. What we're saying here is actually just needs to be rpc.girly.linea.build. It's exactly the same. You don't have to change any of Solidity code. So that's when I'm talking about stuff like StarkNet, for example. They are building in Cairo, so you will have to write a different language and then do it differently. But with Linea, you can do this. Yeah, okay, cool. And so Foundry is kind of how you use that too. I would be pro to explain all of that. So anyways, talking about how you can use Linea in your project. So basically, we have a very open-ended bounty. Basically, all you need to do is deploy on Linea. So whatever smart contract you're building, just go and change this address to linea.build. Show us the actual deployed contract on the Explorer, like the block Explorer. And then that's all the proof you need to actually, and then one more thing. Put keep calm and love Tokyo on your GitHub repo so that we know you actually read these instructions. But otherwise, yeah, it's super simple. I highly recommend doing it. Basically, whatever you build should be able to be deployed on Linea. So yeah, this is kind of information. I have quick starts on actually the full deployment process of like how you set up a project and then actually write a contract and then deploy. I'm sorry, I just assumed everyone was already a smart contract developer. That was like very bad of me. But hopefully you guys will try it out. And that's all I have to say. Does anyone have any questions? Yes.
More of a general question about L2s, not specifically about Linea. On the roadmap for Ethereum, for essentially Vitalik's whole like vision is to bring everything onto L2s and whatnot. And the first step was that all the rollups are being stored in the call data. That the first step would be actually making the call data size larger. I'm still trying to wrap my head around as to how increasing the size of the call data translates into directly the throughput, like the TPS increasing, if you know about that.
That actually surprises me too, that he would want to expand the call data. I don't know. I have 3 very good friends who are like the experts in the room. Do you guys have any idea? If not, I can write down your question and then take it back to my team.
Call data can be treated as a data availability space, and by expanding call data, this was like the simplest way without any more complex solutions on Ethereum to just give more space for storing the proofs. You were sending the proofs through the call data instead of storing them in the storage on Ethereum. You were just passing them in call data because it didn't really need to store them on storage. But instead, now for the 4844 on Ethereum, you providing additional space for data storage that is outside of state, outside of call data. So instead of creating that in the transactions, you create a totally separate transaction type. So it's like continuation of the same thought process of like give more call data, but instead you're providing like the specialized blob transactions that only have call data and only care about that, but they're quite big and they have different rules of propagation. So this is coming potentially in, most likely in Cancun extension in a few months in Ethereum.
Thank you.
Thank you very much.
Cool. So that's my presentation. Let me know if you're building on Linea. I can help you with Solidity development. I can't help you with call data explanations, but that's where I am. Okay. Have a good hackathon.